We start from a previously saved geometry with all the materials assigned. The characteristic width of the floor B is 8 m, so the width of the floor is 4 m. According to ISO 10211, we need a ground with a size 2.5 xp equals 20 m. We hold the X keyboard key pressed in order to draw a horizontal line. Then we press Enter key to manually type the exact length. Let's close the ground's geometry. We need to make sure that the wanted computation algorithm is selected. Now we need to create 3 section elements. One for the above ground wall, one for the below ground wall, we need to make sure that the element's width fully covers the width of the wall. The last section element we need is the one representing the floor. Now let's assign a standard material to the ground area. It's time to properly set the boundary conditions. We start with the adiabatic one. A double click assigns a boundary condition to collinear segments, or hold the left mouse button and pass over boundary lines to set them. The strip tool assigns internal and external boundaries. Every segment sharing the clicked boundary is set at once. Now it's time to simulate. Please notice the psi value among the results. Advanced results show how the software got this value. Wall and floor sections hold the ISO 13370 values used per ISO 10211 option A. Now we want to compute also internal psi. We double-click on floor section elements labels and we enable double length option. We just need to adjust the secondary length to fit the internal floor's dimension. And simulate again. Please notice the 2 psi values among the results. Now we want to compute psi values using ISO 10211 option B method. We need to select the proper computation mode. Generate an area around the whole wall. Remember to include also the portion of the structural part of the floor below the wall. We also need to surround the remaining parts, except the floor, with other areas. We're now ready to compute PSI values with ISO 10211 option B method. Results are very similar. Note: a ground-only simulation ran to get the UG value. The wall has been replaced with adiabatic material, and the other elements have been replaced with ground material.